Welcome back to the Art of Math. Today we're going to go over solving inequalities with absolute values. In the previous video we just did inequalities, so in this video we're going to kill two birds with one stone, which is how to solve absolute values, whether it's equal signs or not, but we're also going to go to the harder route, which is specifically absolute values combined with inequalities. So if you can do the absolute values with the inequalities, you can also do them with the equal signs. Alright, so first of all, this is just going to help inform our understanding. This is a plot of y equals the absolute value of x. So if you plug in 4, the absolute value of 4 is just 4. So what the absolute value does is just return the non-negative version of whatever you plug in. So if you plug in 0, it returns 0. If you plug in -2, it returns +2. If you plug in +7, it returns +7 still. All right, so notice this plot is y equals x, but once you hit the negative numbers on the x-axis here, it's going to flip them to be positive. That's why there's this little kink or bend in this straight line. So that's what the plot looks like, just for your information. All right, so we're going to go through an easy, a medium, and a hard example. So for the easy example, let's take the absolute value of 3 minus 2x is less than 11. Here's how you do pretty much all of these. There's going to be two cases. The first case is the thing inside is unaffected by the absolute value. The second case is that it is affected. So if it's not affected, the left case, we're just going to drop the absolute value. That means this thing is already non-negative. So it's either positive or it's 0. So for the first case, we simply drop the absolute value and solve this just like we would in the previous video. And if you move the -3 over, divide by -2, and remember to flip the inequality, x is greater than -4, that's case 1. Now case 2 means the absolute value is in effect, which means this could be negative. So if this is negative, then after running it through the absolute value will negate whatever's inside. So that's signified by this minus sign that I've tacked on here. So either you have the original thing or the negative of the original. And again, you're going to solve this just like you would normally from what we learned in the previous video. And so once we solve this, we'll distribute the minus sign. -3 plus 2x is less than 11. And if you crunch that through, so add the -3 to both sides, divide by 2, you should get x is less than 7. So for this one, we found that x is between -4 and 7. Now, let's go over to a second example. This one's still kind of easy, but tedious. I've only indicated that it's tedious because now we have two inequalities all lumped into one. So there's two ways to do this. The first method is to do this the way we've just done number 1, which is to first ignore this part. So just solve the left half right here, and then ignore the 12 and just solve the right half separately. And then we can combine those answers. I'm not going to do it that way, but you guys can try it. It should work out very similarly. Just to show you guys kind of a variation on how you can do this all in one shot, I'm going to not split this up into two cases. So this is the no splitting version. So there's two cases in the no splitting version. But by no splitting, I mean we're going to keep all three parts, the 12, the less than this thing, and the 20. So the two cases are the absolute value is in effect or it's not in effect. If it's not in effect, we're simply just going to drop it and solve it without the absolute value. So how are we going to do that? We're going to add this 5 to everything. So it's gone from the middle, and we've bumped these up by 5. Now, so we're just almost treating this as like a double equal sign or double inequality, which is what it is. Now we're going to divide everything by 3. So that's going to give us 17/3 and 25/3, and we're done with the first case. Now for the second case, we're going to negate whatever was inside because now the absolute value is in effect. So now we're going to distribute this minus sign. So that's -3x. Whoa. Oh no, we're all good. We're all good. Okay, so actually what I've done here is I'm not distributing the minus sign. I'm annoyed by the minus sign, which is I first want to divide, or rather multiply, doesn't matter, everything by -1. Now to do that, I flipped the inequality. That's why these signs are flipped over here. So that makes there be no need to apply this minus to everything. So that's where this -12 came from, and that -20 and these flipped signs. So now we're going to solve this one. We're going to add 5 to everything, so that's why these are bumped up by 5, and then divide by 3, which is where we get this range. So x is between -5 and -7/3. So, and all I've done here is I've simply rewritten it facing the other way, so there's just a missing inequality there. The -5 appeared on the right, but since it's the lower number, that's why I've reversed the order and put it on the left here. So we have two solution ranges. Either x is between these two numbers, or it's between these two numbers. So that's how we can solve this problem all in one shot. Now, had we solved it in 2 passes, we should rather get the same solutions. All right, number 3. So this one's gonna be pretty tricky if you've never seen a double inequality in a problem. So I'm gonna give you guys 2 ways to do it. The inefficient way, which we won't do, but I'll just suggest it, would be to split this up into 2 cases per absolute value. In other words, you could treat this absolute value separately, and then you'll have 2 cases. This is an effect, the absolute value is an effect, or it's not an effect. In other words, this is either greater than or equal to 0, or it's negative, or this is greater than or equal to 0, negative. And for each of those, that's 2 cases per absolute value. So 2 times 2 is 4. Now, I don't feel like solving 4 cases, so we're gonna find a way of doing this using only 3 cases. How do we do that? This is the efficient method, what I'm calling the critical value method. So we're simply gonna look at all the absolute value things. So the x appears here, but there's no absolute value, so we can ignore this part. So where you see absolute values, you think about what value for x makes these parts 0. So here we could see that 6 makes it 0, so 6 gets put on our one of our critical values. And if you try to solve this being 0, you'll find that x equals -2 works. So that means rather than there being 4 cases, there's only 3 cases where x is in this region, or in that region. Now you just have to be a little careful about whether you're including the -2 in this region or that region, and the 6 in the B or the C region. So I've defined A, B, and C very carefully over here. So A is strictly less than -2. Now, why did I say strictly? Because if you set x to be less than -2, that will cause this to be negative. If x is greater than or equal to -2, this is fine. This is going to be 0 or larger. And if it's less than 6, then that one's negative. If x is above 6, that means neither of them is negative. So there's only 3 cases. You can't have any which variation. So it's either, to recap, this whole thing is negative, this whole thing is not negative, but this part is negative, or nothing's negative. So, and if you think about why can't, for example, like one be negative but not the other, you'll see why there's no 4th case really. Okay, so here are 3 cases, and now I'm evaluating each of the 3 cases below. So in case A, that means that this part is going to turn out to be negative, so the absolute value is in effect. So in case A, what we're going to do is going to have this thing be negated. That's where this -2x and the -4 came from. Also, if x is below -2, this will also turn out to be negative. So I've negated this whole thing, which is negative of that. But I could also think of it as writing it in the opposite order, which is 6 minus x. If you're having trouble following that, try applying the minus to the whole thing, and you'll see that -x, -6 is the same thing as that. All right, so that's case A. And now we're going to solve this as we normally would solve an inequality, and you'll find that's the solution once you simplify everything over here. Now case B, again, we just have to be careful on how to unwrap these inequalities. So in case B, x is between -2 and 6, but inclusive of -2. So that means that this part will be negative, but this part won't be negative. So that's why this part stays exactly the way it is, but that part is again flipped. And for part C, both of them are unaffected, so we literally just drop the absolute value from both of these. And so for all 3 cases, we're going to solve and get these 3 answers. Now the final step is to remember that, for example, for case C, x is less than or equal to 7/5. We have to remember that this is not always true. This is only true for case C, which assumes that x is already greater than or equal to 6. So you can't be greater than or equal to 6 and less than or equal to 7/5, which is why we've completely rejected this answer. Also, these two answers, they're within the original region. So make sure you further restrict these regions to the original case we're considering. So once you do that, you'll see that there's actually nothing else we have to take into account, and we can combine these two to get our complete answer. All right, so to recap, how is this different than the first problem? We found these critical points of -2 and 6, and then split the entire problem all in one shot rather than one absolute value at a time, so that we only had to consider 3 cases. All right, finally, one last point I want to mention to you guys, which is you might see something like this, and this is just an interpretation question. Absolute value of x minus 40, all of that is less than or equal to 12. So this is not about how to solve this. You should be able, if you've followed number 1 in this video, you should be able to solve this. This is about how do you interpret this. So if you've ever been in a physics lab or a chemistry lab, or it doesn't matter really anything, there's just an intuitive way to understand this rather than just through algebra. You could think of this as saying x is within 12 units of 40, or the error from 40 is below 12. So for example, let's say you want to create a desk, and the perfect size desk is 40 inches wide. However, your person, the guy that's making the desks, is a little sloppy, so sometimes they're 47, sometimes they're 38. They're always around 40, but they're rarely perfectly 40. So this is another way of saying that as long as this error is below 12, you're fine. So the absolute value can be thought of as saying the error, because if it's above or below it, you don't care. It's just going to take the positive value. And so when you see things like this, a lot of people know how to solve them, but they have no intuition behind what this means. So when you see this, you can now understand that this is sort of your error, and this is how far you want to be from a certain number. So if I make this 12, let's say, into a 1, that means you only want your error to be within 1 of 40, so from 39 to 41. All right, I'll see you guys in the next video.